Good afternoon. My name is Jamie Mitchell, and Rex Black asked me to put together a short presentation for his One Key Idea series. And so we're going to talk about performance testing here. Have some slides, and then you free to take questions from you. So without further ado, as a consultant, I've seen a lot of performance testing wasted. A lot of performance tests had no value. One of the main reasons that I think this happens is that a lot of people think of performance testing as being all technical. You have to master a tool. You have to learn how to parameterize scripts and do all kinds of really technical stuff. I find that very often performance testing fails though on the non-technical part. After you've mastered the extremely complex tool set, you have to be able to understand and model the process details. To me, that's at least as important as the tools. Rex and I wrote a book for the ISTQB Advanced Technical Test Analyst course, and in there we adapted a coherent process for performance testing from the Microsoft Developer Network, and that's what I'm going to talk about here. 7 steps. This was adapted from the Microsoft Developer Network. I found over the years that this has worked pretty well for me. 7 steps. Identify the test environment. Identify the performance acceptance criteria. Plan and design the tests. Configure the test environment. Implement the test design. Execute the test. Analyze the results, tune, and retest. I'm going to go through these one at a time for you. First of all, identify the test environment. The fact is that you have to look at what hardware, what software, what network configurations you need in order to be able to do good performance testing. Assess the expected test environment and evaluate how it compares to the expected production environment. Clearly, the closer our test system is to the expected production system, the more meaningful our test results can be. Unfortunately, we have to balance that against cost. While it'd be nice to have a full production environment for testing, we're not going to. In most cases, we're going to have quite a degraded environment. Having the latest and greatest of every tool, along with an unlimited budget for virtual users, would be a dream, but that's as close as you're going to get. It's a dream. Realistically, consider what's likely to happen. Realistically, consider the challenges that are going to be met during the process. A lot of software people tend to be optimists. They feel everything's going to go right this time. We're going to get it right. But the fact is that we don't accidentally get performance testing right. We need to plan, we need to be professional pessimists in order to identify these challenges. Like risk analysis and risk-based testing, we need to always be reevaluating the future based on what we discover during the process. So make your decisions by all means, but understand that as you work with others and as you go through this process, you're going to discover that you were an optimist in some cases. Reevaluate based on what really is going to happen. Second part is identify the performance acceptance criteria. You have to identify the goals and constraints for the system. And what makes this difficult is this has to be done very early in the process, and a lot of the people in the project haven't given any thought to this yet. So as the tester who's going to be doing the performance testing, you need to help focus the project on what we can really achieve. The fact is that people who haven't thought about what the environment's going to look like or what the constraints are or what our needs are, they're going to be thinking about it the first time when we ask them. 3 main ways of looking at what we're interested in. The response time, which is the user's main concern often. The throughput, which is often the business's concern. And the resource utilization, and that's the system administrator's concern. We want to identify system configurations that might result in the most desirable combinations of those 3 things. This might take some doing, since some people in the project, again, haven't even considered this yet. One of the big questions is to identify project success criteria. How do you know when you're done? I often find that there's just that one more test I want to run, this one more thing I want to look at, except that we run out of time. We don't have time to do that. Knowing when we're done is often a very big problem. Now what we want to do is we want to plan and design the tests. We want to determine how to simulate the inevitable variability of the scenarios. What do different users do and how do they do it? This is maybe one of the most important things. Too often I see in performance testing, the performance tester will get a couple of different transactions, and they'll ramp those up and create dozens or hundreds or thousands of virtual users all doing those same transactions. But the fact of the matter is, on your server, you're going to have a lot of people doing different things. For example, if you're modeling Amazon.com, some of your users would be logging in, but they wouldn't be ordering anything. They'd just fall away. And some of them may put things in carts, but not actually check out. And some of them will check out a single item. Some will check out multiple items. Some people will fall out even after they decided to start checking out. You've got all of these different things going on. Don't forget that you're liable to have a lot of people who are working internally in the organization hitting that same server, reading the orders and things like that. And so you really have to determine what different users are going to be using your system and how they use the system. What's the business context in which the system is going to be used? Focus on groups of users. Look for common ways they interact with the system and model that. Remember, the different user groups are liable to have a distinctive differences in the data that they actually use. One of the ways to get information is, if you have an existing system, go into the log files from production. Find out how actual people are using your system. And make sure you define a lot of data. You probably need a lot more test data than you think of. Some people say, well, we'll just reuse the data, but then you have problems with cache irregularities and such. So you want to make sure you define enough data. Review the data you're going to be using with actual users to make sure it's possible that you're being realistic. They can help you find out what you might have overlooked. Ask a lot of questions of people who are actually using the system. And then make sure that you consider timing as part of the data collection. Different groups work at different rates. You've got different personas. You've got experts who are going to spend a lot of time doing certain things. You've got newbies who are going to backtrack, and they're going to want to use a wizard if there is one. You've got people who don't want to use a keyboard. They're going to use tabs. But you want to model all of this, all of these different personas, all of these different work patterns. Because if you don't, you're liable to skew the results. Don't forget user abandonment. Not every task is completed by all users. You want to consolidate all of this into different models of system usage that you're going to test. More is better. It takes more time, it takes more effort, it takes more understanding of what's going on, but the better you do understand, the better you can do this, the more likely you're going to achieve results that are realistic. After you get the data, or maybe concurrently while you're getting the data, you also want to configure that test environment. You want to prepare the environment, the tools, and the resources that you're going to execute the models designed in step 3. Validate that your environment matches the production to the extent that it can, and make sure you document where it doesn't. When you do this testing, even if your environment is completely unrealistic, management is likely to think that it's going to tell them exactly what they need to know. Differences between the test and the production environments, they have to be taken into account, or the test results aren't going to model reality. And the more that you don't model reality, the more management needs to know that. I was working on one project where they had hundreds of servers in production, but they had all of 2 servers that we were supposed to use for the testing. And despite all of the times I complained to management that this wasn't going to be realistic, that it wasn't going to tell them anything, they kept on saying, yeah, it'll work, don't you worry about it. Well, of course, it didn't work. And they got very upset when what we modeled in test was nothing like what happened in production. So do what you can, but make sure that management understands the risks, because that's exactly what it is. If you're not testing in exactly the same environment, you're going to have to extrapolate what your meanings actually mean, or what your findings actually mean. And extrapolation is not easy because it's not a one-to-one relationship. I can't say that because I've got 2 servers, I multiply my results by 50 and it's meaningful for 100 servers. It doesn't work that way. We have to take those differences between the test and production environments and try to understand what it's going to do to our results. Determine the schedule. The fact is that a lot of people do their performance testing very late in system testing. That's a mistake, though, because if you do your performance testing late, then the failures that you find, which are very often caused by design issues, can't be fixed in time to ship on time. And so we want to start testing as soon as we can. But that means that you have to determine the schedule that the necessary features are going to become available. In other words, match up with the software development lifecycle. Not all functionality is liable to be available on day 1 of testing. You have to allow for that. You do want to do your performance testing as early as possible. You want to test during unit testing, test for locks and semaphores and threads and things like that. When you get into integration testing, you want to test subsystems wherever possible. And as soon as possible in system testing, you want to do some performance testing. Even if not all the functionality is there, test what is there. Finally, make sure you instrument the test environment to enable the collection of the desired metrics. Again, you're not going to accidentally find this information out. So you're going to you're going to instrument the environment to find out what's your CPU loading on the servers, what's your network bandwidth, how much of it are you taking. You want to make sure that you collect as much of that as possible, which means instrumenting as early as possible. Now what you want to do is implement that test design. Create the performance testing scripts using the tools that you have. Ensure that data parameterization is as needed. This is a good place to double check that you have sufficient data to run your tests. If you're performing SOAP testing or long-term stability testing, you're going to need a lot of data. My rule of thumb has always been figure out how much data I need and then multiply by 3. You want to smoke test the design and modify the scripts as necessary. A lot of your scripts are going to say, yeah, that's logical, that's going to work, until it doesn't. Make sure that you have time to actually test the design of your scripts, and as you find problems, modify the scripts as necessary. Always ensure before you actually begin the testing that all of your test scripts are meaningful and performing the actual tasks you expected them to. A lot of times, I'm absolutely convinced that this is going to do exactly what I want, right up until it doesn't. Make sure to ask yourself as you start testing, or as you do your smoke testing, do these results make sense? You know, a lot of times we have a hypothesis of exactly what's going to occur, and when it doesn't occur, we figure that we failed. But maybe we haven't failed. Maybe the results do make sense. It's just that our hypothesis was wrong or our design was wrong. Ask yourself, do the results make sense? Now, these smoke tests, these are not reported as part of the official test results. This is all in preparation. Performance testing is one of those things that there are so many different ways to make mistakes, so many different ways that we can fail to model the process correctly or fail to set up the environment correctly. We want to make sure before we test that we do run a lot of smoke tests to make sure that it's going to work. Once we are sure of that, we're going to execute the tests. Run the tests. The first run is often going to show us serious issues that have to be addressed. You want to make sure that the database and the network and the system personnel are there to facilitate the testing. A lot of times our tests are perfectly in order, our environment's perfectly correct, except it's not quite set up or not tuned correctly. The network's not correct, the firewall is not correct. There's a lot of things that can go on. Ideally, any issues would have been addressed during the validation of the scripts. But expecting the unexpected is pretty much par for the course in performance testing. Inevitably, these little snafus come. It's one of the reasons to make sure that we have the experts, the database experts, network experts, system experts available, so that if we have problems, we can find out right away and fix those problems and continue the testing. If you don't have these people available, then what's going to happen is your testing is likely to fail, and you're going to have to wait until the next opportunity. If you're renting your virtual users, or if you're on the cloud and trying to test through there, this is going to get expensive. So make sure that people are available when you're executing the tests to look for problems. Run the testing in 1 or 2 day batches to constantly ask the reasonableness questions. Are the results we're getting reasonable? Are they sensible? Do they make sense to us? Beware a common mistake made among scientists, however. When the results are not what was expected, sometimes scientists believe that the tests are invalid rather than that there might be something wrong with their hypothesis. Eventually, what you want to do is validate that the tests are being run successfully end to end. Repeat the tests. Execute the execute the validated tests for the specified time and under the defined conditions to collect the metrics, but run them multiple times. Again, you're going against a server which is liable to have other processes on it too. You're liable to have batch processes and timed processes and possibly other servers running off of your server, especially if you have a virtual server. And so each run might be different. Each run might give you wide variation between what the results are. You want to run enough times in order to be able to average them out and see. A lot of times I'll have maybe I'll run it 6 times, and 5 times they'll all be close. But the 6th time it's an outlier. It's way off. And it turns out maybe a batch kicked off or something like that, where the CPU all of a sudden got bogged down. You want to make sure that you're checking this. Repeat the test to ensure that the results are similar. And if they're not similar, ask why. Sometimes there might be hidden factors that you didn't understand or didn't see. And then when you stop getting valuable information, when everything's coming up the same, you know that you've run the tests enough. At this point, though, you want to analyze the results. Analyze the completed metrics. Do they prove what you wanted to prove? Do they prove what you thought they should? And if they don't match the expected results, now you got to dig into it and find out why not. Like all other testing, remember, the reason we're testing is to report this information out to the stakeholders. The fact that you had 1,534 users active at the same time is really cool. But the stakeholders are more interested in whether the system will support their needed business goals or not. And so make sure that you report outwards and upwards to the stakeholders in terms that they understand. You probably want to make sure that you talk to them before you're testing to find out what they're interested in. Are they interested in throughput? Are they interested in timing? Exactly what do they want to know? If you have time, tune the system. See if you can get it better. Retest is necessary after tuning. I've seen some cases where we were able to run twice as many virtual users after tuning. It was just a case that the tuning wasn't up, that all of the different people who are part of the system, the database people and the system people and the network people, they weren't really sure how everything was going to work together, so they needed some time to tune the system. If you find that there are major differences, well, deal with it. Can we make changes to the system to positively affect the performance of it? The closer your environment is to production, the more important this question is, because small changes can often create huge differences in the performance of the system. Our experience is that often those changes are negative, where it slows things down. But sometimes tuning them makes it run better. That information is something that the production people are going to want to know. And of course, all of this depends on the time and having the resources necessary. That's my presentation. Questions? Anything you want to? Any questions you have that you want to talk about? Let's see. I've got a Q&A button up here. Feel free to type in a question if you'd like. One of the questions that I often get asked when I am actually doing performance testing is, do we really need the system and the network people there? My answer is always, we're not going to accidentally make this work right. The fact is that accidentally, nothing gets done correctly. What we want to do is make sure, what did Ronald Reagan say? Trust but verify. We think we've done everything right. We think we've got everything set up, but often we made a single mistake, an oversight. Someone overemphasized something that they thought was true, which turns out not to be true. And so having people there makes sense. Question comes in, what tools do I recommend? The fact is that nowadays there are so many varied tools. It's going to depend on your needs. I don't mean to weasel away from that question, Kathy, but the fact is that very often the tools are overkill. The problem isn't in the tools. The problem is in the modeling of the system ahead of time. And so I found that an awful lot of my performance testing is done with a whole lot of different tools, some open source, some fairly pricey vendor tools. But I haven't found those to be the real determinator about whether my performance testing succeeds or not. I'm not sure that answers your question, but yeah, there are some open source tools out there. To be perfectly honest, I'm about 3 years out of date. The last time I did performance testing was about 3 years ago. I've heard some pretty good stories about tools, but I'm hesitant to name tools because they may no longer be available or they might have changed. And so this is one of those things that I try to duck the question. Sorry. Other questions? I'll try not to duck them. Will this slide deck be made available to us? The answer is yes, I believe. I know that this is being recorded, and so the recording is available or will be available in a day or two. I have nothing hidden in this slide deck, so I don't have a problem with it, but that's going to be up to RBCS. Normally, Rex would be here to answer that question, but he was pulled away for a business meeting, and so I don't have an exact answer for it, but I have no problem with it. If RBCS wants to make the deck available, they will. Other questions? There are some notes, so having the deck would be useful because there are some notes I made to myself to make sure that I talked about the things I wanted to. Other questions? Going once? Going twice? I've been agonizing over this for about 3 months since they asked me to do it. It's the first webinar I've ever done. I hope it was useful. I hope it was valuable to you. And if other questions come up, please don't hesitate to ask. Thank you. Enjoy the rest of your day. Thank you, Donna. Incidentally, just for the record, we just last year put together a foundation level performance class, which I think is really useful. RBCS has more information on that. It's a performance test class where we talk about this, but we also talk about a lot more detail, and we'll talk about different tools and things like that in there also. So thank you all. And like I say, enjoy the rest of your day. Bye.